Hey guys, today I'll be showing you guys how to model. So this is some decision science. We'll be using Excel to build a Monte Carlo model. So yeah, here's an example problem. So we're given inputs, like we know how much a car sells for, we know how much we have like the uncertainty, which is the demand, and we're trying to find how many to order. So we can start on a new workbook. So what we are trying to find is the number of orders. Yeah. Okay, next we have some certain inputs we are given. So we are given August cost of 20,000. We also know demand is something that we don't really know. So this is like our uncertain item, which is demand, but we know that it's normally distributed 115. But we can just round that off to give it a nice rounded number because we are looking for a certain number of cars. So that's that. Each car sells for, so August sale price would be 25,000. If demand for next year's cars exceeds the thingy, then reorder cost of 22,000, and then we have blah 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 excess cars, so disposal sale price of 25,000. Oh no, 15,000. That's what it was, right? Yeah, 15. So we need to find the order number. Let me put in a placeholder here and just say 1 for now. Build a Monte Carlo simulation model to calculate the profit for various order quantities. So we want to find profit. Let me move this down because profit is your revenue minus your costs, right? So how do you find revenue? Our revenue would be our demand times our sale price, right? Because that's how many cars are demanded. So we would have 115 somethings, and then we would sell it at this much. So that's our revenue. But okay, we also have to think about how many items reordered and excess quantity. So here it's basically if we order more than we demand. So if we order more than we demand, what does that mean? That means we have an excess, right? Okay, let me move this down here then. If we order more than we demand, we have excess. So if that's a positive number, then that's our excess quantity, but we can't have a negative. So it has to be a max between this and that number. And then we'll do the same thing here, max between, so we need a reorder if demand is, if our demand is greater than however much we ordered initially, that'll be positive, so then it'll be like that. See, basically we ordered 1 and we demanded 116, so we would have to reorder 115 more cars. So revenue, we could do like a disposal revenue too, right? Disposal revenue, because if the demand, let me put in like 200, let's say. So see, the demand, we made money off of the demand, but then since we have this excess quantity, we can still sell that. Oops. So what we can do is your excess quantity times your disposal sale price. So your total revenue would end up being the sum of these two revenues. Okay, so now let's look at the cost breakdown. Your cost is equal to the, well, it is however much we ordered times the August cost. And then your reorder cost, right, is equal to this times your reorder cost. And then your total costs would equal to the sum of these two. You see, if you have no reorder cost, it'll be 0. See, because you ordered more. But let's say it's 1, you have to reorder 75, so then you have that. So then profit is just your total revenue minus your total cost to get this. Now this is the important bit right here. The profit is what we need to find. So we can build a simulation model for various order quantities. I'm assuming, yeah, from 25 to 175 in 25 increments. So the various order quantities that we want to test for would be 25, 50, all the way to 175. So what we can do now from here is go to our simulation settings. Yeah, number of replications, 2000. Our output cell would be profit because we want to find the mean and stuff for the profit. And then we do have a decision variable. The decision variable is how many we're ordering, and that is the label for it. And then here are the values that we want to test for. So now that we have that, we can click OK and go ahead and run our simulation. So depending on how many iterations you're gonna do, like the 2000, 3000 replications, that's how long it'll take. Not too long. But so here we're looking for what is the mean profit for 25 and for 175. So based off of our simulation, our, oh, look at that. Our mean is this number here. And this is this, or 175. Awesome. Now, which order quantity results in the greatest mean profit? What we can do here now is just find the max of all of these numbers, which is, what is that? 100. Okay, and then which order quantity should we select if we want to maximize our mean profit? Okay, so we want to find the max, but also have a 95% chance of greater than 300,000. So what we can do is go down to our probabilities, 300,000. 300,000, yeah, that's right. And then bam, 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 bam. So it has to be greater than 95%. So only these two, we're only looking at between 50 and 75. Between that, to maximize our mean profit, 75 is greater, so we'll do 75 because, I mean, that looks bigger. Yeah, that's about it. So that is how you answer that. We can upload our Excel file. Where did I save this to? My OneDrive, bruh. iCloud Drive? I actually don't know how any of this works, but essentially that is the case. Now if we want to look at all these other stuff, I can go through these as well. So really fast, you just need to see cell B5. What is that? B5 is your cost. So this is asking, oh, look here, the unit cost has a triangular distribution. This is just asking you to go in and put triangular with a minimum of 8, 10, 12. You just need to know that that is how you build out the function. In cell B8, we are looking for unit sales. So the sales would be the demand or the capacity. So you would do minimum equals minimum B3 E3 Perfect, right there. So this is an output. You also need to know how to look at the outputs for simulation. So do larger plant sizes. So as this number goes up, does it have higher or lower risk? We can see that the standard deviation tends to be going up, so we would go higher. The expected net income, so our mean net income for the production level with the highest mean. So we'll just try to find the highest, and the highest here is 193,324. 193,324. And then the next question is asking for the standard deviation associated with that level of output. So 234,581. 234,581. So that's all of that. That is how you do it. Oh, here are some conceptual questions. We can go over this too. How does increasing the number of trials affect the results? It'll increase the accuracy. What statement is true about Monte Carlo situations? They can predict timing? No. They require assumptions about distributions? Yes, because it was working with probabilities. Let's see. Nope, that's not true. Eliminated all? No. Monte Carlo simulations are particularly useful for deterministic? No. Risk and uncertainty? Yes. These two? No. What differentiates a Monte Carlo simulation from a deterministic? Monte Carlo, yeah. So Monte Carlo is not deterministic. Deterministic means you have your values, no probabilities, no randomness, but Monte Carlo does. The primary, so sensitivity, you want to see how sensitive a model's output is to changes in its inputs. So, yep, same thing here. Sensitivity analysis evaluates how changes in input affects the output. The flaw of averages says that the average out of the model output from a Monte Carlo simulation is often incorrect and misleading. That is false. Flaw of averages says that the average, like when you put in an average input, you won't always get an average output. And that's how you do it. Let me resave this somewhere else. Let me put this into... I don't know why this is like this. Exam 1 Sims. Okay, so if I maybe I have to exit it to upload the file. Why? Where's my exam 1 Sims? Bro. Oh. No. Where did my exam 1 Sims go? Wait, I totally lost it. Where'd it go? Oh, here. What is wrong with this? Why? What? Why is it built like this? Hello? Oh, whatever. It's okay. Just know that it's right.